Hey guys, welcome to Code Caffeine. Today we're gonna do the medium difficulty problem from Leet code. It's called count good nodes in a binary tree. So let's get started. Let's study the problem first. So given a binary tree root, a node x in the tree is named good if in the path from root to x there are no nodes with a value greater than x. Return the number of good nodes in the binary. Okay, so what the question says is that if there is an if a node doesn't have any greater number above it up to the root, then it is a good node, else it is a bad node. So for example, 3 is the root node, so it's obviously a good node. It will always be a good node. So let's go to 1. 1. If we see 1, then we traverse back to the root. We see that there is a node having greater value than 1, so it is a bad node. So if you go to 3, then we can see that there is no there are no any nodes that are greater than 3, right? So it is a good node. So similarly, if you go to 4, then 4 is greater than 3, so it's a good node. If you go on 1, then we encounter 4, which is greater than 1, so it is a bad node. Similarly for 5, 5 is greater than 4 as well as greater than 3, so it is a good node. Okay, so what we need to do is like we we just need to pass the maximum the maximum the maximum value. So 3 4 1 and a 5. Okay, so what we need to do is we need to we need to make a function. Let's at first we need just count it equals to 1. Why we are doing 1 is because we will always uh, the number of nodes is will will always be in the range from 1 to 10 to the power of 5. So there will always the root node will always be a good node. So we count it as a 1. So now we make a function called const count good node, and what we have is we take we'll get a node and max val or max value. Now we return count and we call count good node root dot we pass root dot left comma root dot val, and we call root dot right with root dot val. So what we are doing is calling the count good node function by passing this node and this value. And the other thing we need to do now is so if no node, we just return. That is, if there is no node, then we just return we just break that loop. Else we gonna sorry we just gonna return from that we just gonna return from that function. Else if node dot val is greater than or equals to max val, then we increment the count. So we do that, and the other now we do the same in here. Count root dot left, instead of root dot left we'll do node dot left, and in here we need to be instead of we do mat dot max val comma node dot val. I'll explain it in a bit. So what we did here is, so if there is no node, then we just return and in that function. And in here what we did is we checked if the value is greater or equals to the maximum value. So we passed maximum value for the first iteration. um, the maximum value is the value of a root node. So we have 3, we passed 1 and 3. We checked 1 and 3, and i- is 1 greater or equals to 3? No, so we didn't, so it didn't increment the count. Now what we did is we went count 1 dot left, so 1 dot left is 3, right? So in here it goes 3 comma 3, and math dot max so max val is currently 3, and node dot value is 1, so it will pass 1, sorry, it will still pass 3. So we again compare 3 comma 3. Now it is equal, it is equals to 3, so it will increment the count. So for 4 we pass it, we pass the node 4 and 3, which is the max val. And if you compare it, 4 is greater than 3, so it will increment the count by 1, and it will go to the left, and it will go it will, and we will call for the left node, but we have math dot max 4 comma 3 now, right? So it will pass 4 now. So why is 1 greater than 4? No, so it will end it here. Similarly for here we will go 5 comma 4, we will pass the node 5 and pass math.max 4 comma 3 for the right. Math.max, here max val is 3, node dot val is 4, so it will pass 4, but 5 is greater than 4, so it will again count, it will again increment the count by 1. So, and at the end we return the count. Now we run the code. Yeah, and it's working. So let's submit it. Yeah, so it works. Thank you for watching. Hope you liked it. Feel free to subscribe. Thank you.